All right. Now that we've finished covering the notes, we're going to go ahead and do two example problems so y'all can see it actually done with real numbers in here. So we're going to go ahead and jump right into it. So let's look at this first one here. Let me pull up my tools again. All right. So this first one on the left here is y equals x squared minus 2x minus 3. So first thing we want to do is probably try to find, we could really go about this finding anything we want. I think I like finding my intercepts the most, so my x-intercepts and my y-intercepts. And since x-intercepts are usually the little more lengthy ones to find, let's go ahead and get those out of the way first. So we covered our quadratic formula, which was x. Let's make this a little smaller. Equals negative b plus or minus the square root b squared minus 4ac all over 2a. Now, normally when I'm doing this, I would just plug in the numbers and put in a calculator. I'm going to do that with the second one, but the first one I want to go ahead and work out just to show you how to do it if you want to actually work these out. So what I'm going to do is I'm going to start putting in, and we're ignoring this one right now. We'll come back to that in a little bit. So I'm going to put in my A, B's, and C's. So what are my A, B's, and C's here? Well, my A is this first spot where the x squared is, but we don't see a number there. So it's really just a 1. It's an invisible 1 in front of it. B is our second number, which is a negative 2. You can see it in the middle there. And our last one, C, is the last number there, which is negative 3. So I just take these values, and wherever I see an A, B, or C, down in this, I'm going to plug in. So this negative B would be a negative 2, plus or minus, and then a negative 2 squared minus 4 times 1 times negative 3, all over 2 times 1. So I'm going to go ahead and write that out. So I got x equals negative, and then put parentheses, negative 2 plus or minus square root negative 2, put that in parentheses as well, squared minus 4. I didn't really make that long enough. 4 times 1, because that's our A, times negative 3, because that's our C. All over 2 times A, which is 1. Okay. And here's the problem we get with this. We kind of run out of room. Let me move my picture up to the top here. Come back to that one. All right. So I'm going to simplify this. We got x equals, well, negative 2. This first part here, that's a double negative. So I'm just going to change that to a positive 2. So 2 plus or minus square root 2 squared, 2 squared, negative 2 squared. So negative times a negative is positive. And then 2 times 2 is 4. So it's going to be a positive 4. So I'll put that in. And then it's minus 4. So negative 4 times 1, that's just negative 4. And then we got negative 4 times negative 3. So 4 times 3 is 12. And negative times a negative makes a positive. Plus 12. All over 2 times 1, which is at the bottom, it's just still 2. That already cut it down quite a bit there. So now we got x equals, I'm going to keep that 2 the same for now, 2 plus or minus 4 plus 12 is in that square root, which is 16 all over 2. And then we got x equals, I'm going to leave the 2 alone again because I want to figure out what's the square root of 16. Well, we've got to figure out what times itself is that number. Well, in this case, it would be 4 over 2. And when I say plus or minus in the middle here, this plus or minus, this essentially means we're just shortening it down to, it looks like one problem, but it's really two. We're doing 2 plus 4 over 2 and 2 minus 4 over 2. So that's going to give us two different answers here. So we can do the first one, which is 2 plus 4 over 2. So 2 plus 4 is 6 divided by 2 is 3. And then we got our second problem here, which is 2 minus 4 over 2. So 2 minus 4, but our minus number is bigger there. So we're at negative 2 divided by 2, give us negative 1. There's an equal sign there. So that tells us our x-intercepts. So we got 1 at, I'm going to use a different color here for the actual graphing and make it a little bit bigger. So we got 1 at negative 1 and 1 at positive 3. So we got our first part done, and that's honestly the longest part. So let's go on to the next part. I'm going to go and clear this out to make some room. And if you need more time to look at this, just pause the video, rewind it, whatever you need to do. Just trying to clear up some room. All right, so next, remember I was saying I like to find my intercepts first. Well, I found my x-intercepts. Now I want to find my y-intercepts. So, to find my y-intercepts, talked about this a little bit in the notes again. I'm going to use red this time. We use our, we actually don't have to use equation here because we just look at our original problem here, which was y equals x squared minus 2x minus 3. And all we do to find our y-intercept is we plug in zeros for these x values. So this one and that one. So we get y equals 0 squared, which is just 0. And then y equal minus 2 times 0. Negative 2 times 0 is just 0. So it's just a plus or minus 0 here. It doesn't even matter. And then at the end, we got our minus 3. That doesn't change. So all we really have is y equals negative 3. Maybe you can see something here. This is a quick way to figure this out. You can just look at this last number here. And look, it matches up with that one right there. So that tells us our next point. So I'm going to go and plot that on here too. And remember, this is the y-intercept. So we look at our y-axis, which is this one running up and down. I'm going to go down to negative 3 and put a point there. It's a little high, but it should be on that negative 3 right there. So we're almost done with this already. So I'm going to go and clear this now too. Now I would want to find my line of symmetry. So, or my axis of symmetry, I'm sorry. So, remember axis of symmetry, it's that dotted line that runs up and down. It's the one that divides our graph evenly. So to find that, I used something else the other on the notes. It was x equals negative b over 2a. So this should still be on your notes. And this one, we're just plugging in the numbers again that we got earlier. So b is negative 2, a is 1. So that's what I'm going to do. So x equals, so negative stays out front, and then we got a negative 2, because that's what our b is, over 2, and then a is 1, so 2 times 1. So I can get rid of these negatives here, because we got 2 of them right next to each other. So we really just got positive 2, and then 2 times 1, that's just 2. So 2 over 2, we know what that is, that's just 1. So x in this case is 1. So we go to our 1, which is right here. I'm going to switch to blue again since we're drawing on. Actually, I want to just leave this. I'm going to make that. I'm going to keep that green. Okay, so we're at 1. And this is a vertical line, so it's straight up and down. So I'm going to make a dashed line going through here. That's what that's going to look like. So again, I'm going to erase all this. Actually, going to keep that x equals 1 down there because I know that's my axis of symmetry. I think I'm actually going to label it too. So I'm going to put AOS for axis of symmetry. And then go and get rid of the rest of this. All right, last part. So now we're looking for, we're looking for our vertex. So our vertex, kind of similar to how we found our y-intercept. Remember we put zeros in for x's here at the top here. For this right here, we put in zeros wherever we had an x. Now instead of putting a 0, we're putting in this, our 1. So we're going to go ahead and do that. So we have, I'm just going to rewrite it here, y equals x squared minus 2x minus 3. Now I'm just going to replace my x's with 1s. So y equals 1 squared minus 2 times 1 minus 3. So now we can figure this out. 1 squared just stays 1. Negative 2 times 1, just negative 2. And negative 3, negative 3. So now we got 1 minus 2 is negative 1 minus 3. So negative 1 minus 3, that's negative 4. And there we go. So on this line, we go down towards negative 4. So if we're counting downwards, so remember it's this line on the axis of symmetry is where we follow it. So we go down 1, 2, 3, 4. So I'm going to put the last point right there. That is. Now all we do is try to make this look as clean as possible by connecting these. So it has to look kind of like a U. I'm not going to be too picky about it because my U is not even looking that great. I'm going to change the color of these points so you can actually see them even through there. And there we go. We're done with it. So I'm going to do one more. So I'm going to erase all this. And again, if you need time, just go ahead and pause the video. But I'm going to go ahead and jump into it now. Okay, first thing first, going to find those x-intercepts. So wherever it crosses here on this line right here. So I'm actually going to scratch this other one out so we don't get it mixed up. It's our old one now. Okay, first thing I'm going to do is figure out what my A, B, and C is. So I'm going to look up here. A is, so in this case, it's just a negative x squared. So there's really a 1 in there. We just don't see it. So it's really negative 1. B, just like our last one's negative 2. And C is 3. So now we look at our quadratic formula. I'm going to write it over here. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So again, we just plug in those numbers. So wherever we see a b, we put in our b's. Wherever we see a's, wherever we see c's, that's what we're putting in. So we got negative, and then b is negative 2, so negative 2 plus or minus square root b squared, so it's negative 2 squared minus 4. You can already see I'm running out of space again. I'm actually going to, I think I'm going to write it down here anyway. So x equals negative 2 plus or minus. So negative 2, should go in parentheses, squared minus 4. It's 1, negative 1, positive 3. Let's get rid of that old one. Kind of ran out of space there. And this is all over 2 times negative 1. Yeah, I think I'm just going to have to get better at writing with this because, wow. Just got to take my word, those are actual numbers. So this time, I'm going to actually just use my calculator instead of doing all that work again. So just give me 1 second to put it in here. And again, you can follow those same steps we did in the last one if you'd rather work it by hand, or you can use a calculator here, whichever one you'd prefer. Just got to give you 1 second to write it in. Okay, and just like that, we are ready to get our answer, and that would be, we have x-intercepts at x equals -3 and at x equals 1. So, see how much quicker that was? So I like using a calculator if I can. So I'm going to go back to -3, make a point, and at 1 and make a point. Remember, these are x-intercepts, so it goes on the x-axis. All right, so let's get rid of this. And then we're going to do our y-intercept. I don't know if you remember how we just did it a second ago, but that's how when we put in zeros for our x's. So that's what we're going to do here. All right. So we got originally y equals x, I'm sorry, negative x squared minus 2x plus 3. I just copied that right up there, brought it down here. Didn't do anything else yet to it. Now again, look at our y-intercepts, so we're just putting in 0 wherever we see an x. So y equals negative, I'm going to put a parentheses, 0 squared minus 2 parentheses 0 plus 3. Remember what I said when we did it last time? Instead of just thinking about like 0 squared is 0 and stuff, we could really just look at this last number here. In this case, it's a positive 3. So number y is going to be equal to positive 3, or just 3. You don't even have to put the positive there. So again, this is a y-intercept. So we look at our y-axis, which is the one that runs straight up and down. We're going to put a point at 3. That's all we do for that one. So we're already almost there. Just got to do axis symmetry and then our vertex. Okay, axis symmetry. Remember we used that equation we just used a little bit ago. Let's switch back to red in this case, which was x equals negative b over 2a. Again, we're just plugging in our values here. So what's our negative, or what's our b here? It's negative 2. So negative 2 goes here. I'm going to keep it in parentheses. I just like putting all my stuff in parentheses. And then that 2 doesn't change, and our a in this case is negative 1. And again, we can get rid of these negatives here because they're right next to each other. So double negatives, those just become positive anyways. So we really got here 2 over 2 times negative 1. What's 2 times negative 1? That's negative 2. So this is really 2 over negative 2. And 2 divided by negative 2, what's 2 divided by 2? That's 1. But we got 1 positive, 1 negative in this case, so we really have negative 1. So our axis of symmetry, I'm going to put AOS, is at negative 1. So we go to where our x-axis is negative 1. I'm going to keep this in red. And we make a dashed line going through it. Cool. We got one more thing to do now. So I'm going to get rid of all this other stuff real quick. I'm going to keep the axis of symmetry down there. I want to make sure not to erase it. All right. So axis symmetry, we do it really similar to how we found our y-intercept. Again, remember how we put in zeros for x's when we wrote this down. Negative x squared minus 2x plus 3. We did put in zeros for those. Now we're just going to look at our axis of symmetry down here. And we're going to put that negative 1 in instead. So we got y equals negative 1 squared minus 2 negative 1 plus 3. So now if we figure this out, we get it's negative 1 squared. That's negative 1 times negative 1. That's a positive 1. But we still got a negative 1 out here, so it really just stays negative 1. It's almost like we had 3 negatives there. So then we got negative 2 times negative 1. Negative times a negative is a positive, so that becomes positive 2. And then at the end, we just got positive 3. That doesn't change. So we got negative 1 plus 2. That gives us positive 1 because it's the same thing as saying really 2 minus 1. So we got a 1 plus 3. 1 plus 3 is 4. So now we go, I'm going to use blue one more time. So now we just go to our axis of symmetry, that dashed line on our graph, this one right here. And I'm going to count up to 4. So 1, 2, 3, 4. And put a blue dot there. So I'm going to draw my graph in orange now. And now all we do, connect those points. Try to make the U as good looking as it can. There we go. And in this case, you notice how the U is upside down. That's because our quadratic up here that we started with has a negative at the beginning. And that tells you whether it's facing downwards or upwards. So our first one, it was facing upwards, something like that, because it was a positive. This one, it's negative, so it's pointing downwards. And that's all I have for you. So again, if you have any questions or if you want to rewatch this to get a better hang of it, go and do that. And if you got questions, just come to the office hours. I'm more than happy to answer any questions you got. All right. Hope you have a good rest of the week.